the first tutorial of section 2.4, we will learn about solving quadratic equations by completing the square. We are going to use the completing the square technique that was our objective in section 2.3. So we can solve quadratic equations in another way by using completing the square. To simplify this, we will move to solve example 10 on page 20. In this example, we are going to explain the steps that we should follow in order to find the roots of the equation if they exist. If I have to solve the equation x squared plus 8x plus 10 equals 0 by completing the square, then the first step to solve the equation is to rearrange it in the form of ax squared plus bx equals c, x squared and the x on one side and the constant on the other. In completing the square technique, I should have x squared and x to apply the general formula. In the example, x squared plus 8x plus 10 equals 0. If I want to rearrange it, I need to keep the x squared plus 8x in the first side and move the 10 to the constant side. So it becomes x squared plus 8x equals minus 10. Now I have x squared plus 8x equals minus 10. Then we check the coefficient of x squared is equal to 1. If I have no number in the coefficient place, then the coefficient is 1. So this step is checked. To apply completing the square, x squared plus bx as in x squared plus 8x, therefore b equals 8. According to the formula, x squared plus bx equals x plus b divided by 2, all raised to the power 2, minus b divided by 2, all raised to the power 2. Since b equals 8, then the equation will be x plus 4 brackets raised to the power 2 minus 4 squared equals minus 10. Since 4 squared is equal to 16, so we write the formula as x plus 4 all to the power squared minus 16 equals minus 10. To follow the technique of completing the square, which are the brackets to the power 2 equals constant. So minus 16 must be moved to the other side to become plus 16. Then the equation will be x plus 4 raised to the power 2 equals minus 10 plus 16, where minus 10 plus 16 equals plus 6. Now we can apply this formula x plus b divided by 2 all raised to the power 2 equals constant, since we have brackets raised to the power 2 equals to a constant, which must be greater than or equal to 0. And here we have plus 6, which is greater than 0. Let's remember that when solving the quadratic equation, we solve this expression by applying the technique of square root. Now the square and the square root cancel each other, and the solution is either x plus 4 equals square root of plus 6, or x plus 4 equals square root of minus 6. To find the roots, we have to find x. The equation becomes x equals to minus 4 plus square root of 6. Also, here x is equal to minus 4 minus square root of 6. Since minus 4 is common in the two solutions, so the roots are written in this way. X is equal to minus 4 plus or minus square root of 6. Therefore, here we are going to solve the quadratic equations using the completing the square technique. Now note that when we have a square root and we can't get the number under the radical, then we keep the solution or the answer in. I can't get this answer by factorization, so some of the quadratic equations can't be solved by factorization. So we use the alternative method, which is completing the square method.